Hello everyone, my name is Raj Ramaswamy and I'm the lead marketing data scientist for Bidding, Bathing and Yonder company, and I have been tasked with modeling household revenue for a predefined household data set of loyalty customers for Bidding, Bath and Yonder company. And I've done my analysis and I'm here to share my analysis and insights and also walk you through the model that I developed and deployed to predict the outcome. Here's the agenda for today. Executive summary. I'm going to walk you through the methodology, and then I'm going to share the model assessment results, and also some of the insights from the data analysis that I did. So the objective of this exercise is to create a predictive model to estimate the household spend for bidding, bathing, and yonder prospect customers. The model would enable the marketing team to tailor customized offers to prospective customers, which in turn will increase revenue and drive engagement. So key findings. So I developed and deployed three models, and then out of the three models that I developed and deployed, tested linear regression, K-NN, random forest. The K-NN model had the lowest RMSE and MAPE values on both validation and test data, and also it had the highest R-square on both validation and test data. And then from the modeling exercise I did, identify the following important factors that impacted the household spend. Those are home ownership and dwelling unit size, net worth and lifestyle, education, median education years and occupation industry, and also magazine subscription. I'll be talking about in detail about all these insights later in this presentation. So here's a methodology similar to a previous exercise on modeling. I've leveraged the SEMA methodology, which is sampling, exploring, modifying, modeling, and assessing. Under sampling, obviously we had like 5 different kinds of data. One was the consumer data, one was the donations data, one was the magazines data, one was the political data, and one was the in-house data. Under exploration, I used histograms, frequency counts, correlations, grouping, and other things to really understand the data and do some analysis. And then the third thing is modifying. So modifying is a process of selecting the variables required for the model, and I use I kind of figured out like what variables are really important, what variables are ethical and non-ethical to figure out which should be included in developing the model. And also I this is the first time I've tried designing to understand the high spenders and the profile. And then I also use the V3 feature engineering tool to really take care of the categorical variables and also solve for the missing values. In terms of modeling, I tried 3 different models: linear regression, K-NN, and random forest. And then once I developed the model, I tested the models on training, test, and validation data, and I looked at the following metrics such as RMSE, MAP, and R squared to really understand like which model is the best model to explain the outcome or predict the outcome. So, and here's the model assessment method. So we took the data and then we divide the data into training, validation, test portions, and then the models were tuned and compared uh, based on the validation portion, and then it tested the model on the test data to predict the true way the model would behave when launched on new data. In terms of variable selections, I excluded all the variables with more than 50% missing values, and also excluded all the variables which were unethical to use, such as variables that corresponded to ethnicity, gender, political affiliation and political views, religion and religious views, donations to non-charity organization, gun ownership, and veteran status. So here's a summary of the results of the model assessment. So if you look at the top left-hand corner, this is the graph that shows RMSE values for both for the training, validation, and testing data. And if you look at the training, the linear regression model had the lowest RMC, followed by KNN, and then random forest the highest RMSE. But if you look at the validation and the testing data, the KNN had the lowest RMSE score. I mean, the lower RMSE means the model is better. So KNN was really, um, I think KNN was at the lowest RMSE value in terms of the model fit. And then if you look at the bottom left-hand corner, this is the MAP value. And again, if you look at across training, validation, and testing, the KNN had the lowest value. The lower the value, the better the model fit is. And then the last important metric is R square. And R square, if you look at the training, the linear model had the highest R square of close to 0.66, which I thought was pretty good considering the data that we had for this model. And then, but if you look at the KNN, right, I think it did really good on the validation testing data. So, so though the linear model and the KNN model were kind of performing equally, but since the KNN model KNN model did extremely well on the validation testing data, so I preferred using the KNN model to predict the outcome on the prospect data. So again, if you look at the KNN metric, KNN on the validation data had an RMSE of 74, MAP of 0.21, and a half square of 0.45. So, so one other thing I did was like performing decile analysis to kind of divide the data set into 10 equal groups and categorize highest to lowest based on spend. So if you look here, obviously the top 5 deciles, they spend more than $300. The average spend is $300, but the top deciles, um, they spend more than $300, and they also contribute to 63% of the overall spend here. And then the next thing I did is like really understand the profile of the top customers, right? The top 3 deciles. So if you look at the top 3 deciles, right? I mean, these customers are more likely to be a homeowner than the average, right? So, and then, but interestingly, interesting data was that this group also had more customers than average who are less likely to dwell in a single family home. The next one is I looked at net worth, and then kind of shows that the top spenders have a higher distribution of customers whose net worth is between $50,000 to $250,000 and above $500,000. And then the second thing, I looked at the mosaic consumer groups, which is basically a behavior segment that Epsilon created. And then based on that, the top spenders have a higher percentage of customers belonging to aging in place, aging of Aquarius, and no place like home. And it has a lower percentage of customers from rooted flower power and then silver sophistication. So the green means like they are better than the average. So 1.96 is better than 1.83. Um, you know 2.02, that means like they had a higher distribution compared to the average of 1.89, right? So this is how you kind of read the data where uh, it it shows the distribution of the particular category in the top 3 deciles, and then the bottom row shows the what is the average distribution of the particular category for the entire population. Similarly, if you look at the profile of high spending customers, the top spenders have more customers than average management jobs and also with some college bachelor's degree. And then of all the variables, magazine purchase behaviors are highly correlated with high spenders. Customers with magazine purchase have the highest potential to spend at BBY. So here's a summary of profile of BBI target market. So basically, the key features that I was able to leverage on data is these customers are middle to upper middle class seniors and upscale boomers. They live in multi-generational homes. And then the contribution to charity. They are avid newspaper and magazine readers. they are mostly management jobs or own a business, and they're financially secure. In terms of demographics, they're probably in the age group of 51 to 75. They have household income from 50 to $50,000 and household size of 4 plus. And here's some appendix exhibits that if you're if you have time, you can kind of go through it. But kind of shows like the things that I did in terms of correlation, and then key insights from the linear regression model, and then key insights from the K-NN model, and then key insights from the random forest model. And that's pretty much for today. And if you have any questions, please don't hesitate to contact me. And thank you so much. And it was a really great, it was really exciting to work on this project. Thank you.